we have a complex rational expression, fractions within fractions, and there's different ways of doing this. One option is to ignore the bottom and just work on the top. You need a common denominator to be able to add these two fractions, and you would get an answer up on top. I'm just going to put A for an answer. And then you would ignore the bottom, and there is nothing to work out, so technically you have another answer down here. And then after that, what you would have to do is take the first answer and then multiply by the reciprocal of the second answer. Right? Now that's the long way of doing it. So I'm not going to explain the long way. I'm going to go with the shortcut, the fast way of doing it. So right here we have the same problem written over again. And the easiest way to simplify this problem is to identify the LCD of everything. All right? I'm not just talking about the LCD of this one and this one. I'm talking about the LCD of all three denominators. And in this case, it's the same LCD as the top. So if you identify the LCD, the lowest common denominator, which is 12 times x minus 5, and then multiply everything, every single thing, by 12 times x minus 5. So check this out. I want to put a 12 times x minus 5 right next to each fraction. And what happens when I multiply every single fraction by that LCD, 12 times x minus 5? Well, this x minus 5 cancels with that x minus 5. And what do we have left? We have 12 times 2. And let me rewrite a fraction down here. And let me start writing down my answers on this fraction. Like we said, 12, that's left over right here, times 2, that's going to give us 24. And now over here, when you multiply this with this fraction, the 12s cancel. So let me cancel out those 12s. And what we really have is a binomial x minus 1 times a binomial x minus 5. So we need to actually distribute x times x. That's going to give us x squared. Okay, let me write this answer up here, x squared. And then x times negative 5 is a negative 5x. And then negative 1 times x is negative x. Then negative 1 times negative 5 is positive 5. So we have the quadratic trinomial x squared, bless you, we have this quadratic trinomial x squared minus 5x minus x, so that's going to be a minus 6x, and then plus 5. Notice that there's a plus sign between the two fractions, original fractions, so I don't have to worry about changing any signs. I could just get this and write it down right here on our answer. So our answer will be the x squared that you see right here. So positive x squared. We also have the minus 5 and the minus 1. That's a minus 6x. Let me extend this a little more. And then we also have that plus 5. Okay, so that's what we have on top. We already did the top. Now let's multiply this bottom fraction by the LCD. And you're going to cancel out the x minus 5 down here with the x minus 5 up there. And we still need to distribute the 12 into both terms. 12 times x is 12x. Now remember, this is the bottom part. So this is the bottom part of our answer. 12x on the bottom. And then 12 times 3 is 36. Is everybody with me? Okay. So we have our answer so far, but we could make it look nicer. All right. So what I'm going to do is put it in order. I want to put x squared. I want to put the minus 6x next. And the 24 plus 5 is positive 29. And that's on top. And on the bottom, we still have the 12x plus 36. Now, I do notice that I have a quadratic trinomial up here on top. So maybe we're able to factor, split, and solve. Maybe not. I don't know. What times what is 29 that if you add together is negative 6? Doesn't work. So we cannot factor the top. Even if we could pull out a 6 on the bottom or even a 12 on the bottom, it's kind of pointless because nothing else cancels. So I'm assuming that this is our final answer right here. Let's verify that on the worksheet. Let's see. So when we look at our multiple choice answers, we do have the quadratic trinomial on our multiple choice answers, x squared minus 6x plus 29, x squared minus 6x plus 29, but they definitely pull out a 12 from the bottom. Let's see what it would look like if we pulled out that 12. So from the bottom, if I pull out a 12 from there, you're going to end up with a 12. Let me actually move this up. You're going to end up with a 12 on the outside and an x plus 3 on the inside. So you could scratch that bottom part out and rewrite it as 12 on the outside, x plus 3 on the inside, and that would be your final answer. So if we go over here, it is option D. So even doing the shortcut still took a while, right? Hopefully you guys understand that one. If you do understand it, you should be able to do the next one. Check your answer to make sure that you got it down right. So let's jump to number 39. You guys can try 38 on your own. Question? Okay, so on number 39 and 40, we have equations that have radicals in them. They have square roots in them. And we should all remember that when you're solving an equation and you want to get rid of something, you do the opposite. So the opposite of a square root is square. So what you do to one side, you do to the other side. So by squaring it, it'll get rid of the square root. Now, on the left side, it's pretty simple to understand that you just end up with a 13x. Maybe I should zoom in on this a little more. And on the right side, it's a little bit trickier because on the right side, you really do have 3 times x plus 4 times 3 times x plus 4 in the square root. That is disgusting. I apologize. But anyways, what you could do is rearrange it and say that you have 3 times 3 times the square root of x plus 4 times the square root of x plus 4. And what ends up happening is that the square root and the square root, when you multiply them together, the square root disappears and you just end up with the binomial x plus 4. Does that make sense, even though it's all messed up on the screen right there? When you multiply a radical with itself, the radical disappears and whatever's inside is what's left over. So what we really have on the right side of the equation is 3 times 3, which is 9, the 3 times 3, and then the square root times the same exact square root value. It's going to be just the binomial x plus 4. Does that make sense? Yes, it does. Okay, good. So now we're going to distribute 9 times x and 9 times 4. That's going to give us a 9x plus 36. And over here on this side we have a 13x. And now all we have to do is solve by moving x's to one side. I'm going to subtract 9x. And I'm going to subtract 9x. I'm going to end up with 4x, I'm sorry. 4x equals 36, which means that x equals 9 if you were to divide both sides by 4, which means that the answer is C. Okie dokie artichoke? All right. So if you guys understood that one, and the key here, again, let me repeat it one more time. The key here is to understand that when you multiply a radical with itself, the square root disappears and the inside binomial is what's left over. Yes? Good question. Can you guess and check? Can you just plug in 9 and see if it works? Yeah, you can. He'd have to guess. Yeah. I mean, of course, you might get lucky, plug in 9, it works the first time.
Yeah, because that's what I did right now. I just did it in my head.
Yeah, you could guess and check. I don't recommend it, but yeah, you could do that, especially with these multiple choice questions. Let's skip 40, go to 41. Where's 41? Another square root problem. It's done the same exact way, same concept. How do you get rid of a square root? You square it. So you're going to square both sides of the equation, okay? So, yeah, on the left side, you end up with just x plus 5 on the left side. X plus 5. And on the right side, you have to do some work. Now, what do I mean by that? You have to write it twice. X minus 1 times x minus 1. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is another negative 1x. Negative 1 times negative 1 is positive 1. Combine the middle terms, you're going to end up with x squared minus 2x plus 1. So on the right side, you really do have that quadratic trinomial x squared. Let me make some space here. Forget the space. X squared minus 2x plus 1. Ignore the blue, just focusing on the black right there. So we have a equation that has a quadratic in it. So it'd be a great idea to move everything to one side, set it equal to 0. That way you could use a quadratic formula, or you could try to factor, split, and solve. I'm going to do 2 steps in one. I'm going to subtract x and subtract x. And I'm also going to subtract 5 and subtract 5. So my new quadratic trinomial equation will say 0 equals x squared minus 3x minus 4. Okay, now it doesn't matter if you have the equal 0 on this side or if you put it on this side. I like having it on the right side. Anyhow, we have a quadratic trinomial. Question is that quadratic trinomial factorable? What times what is negative 4 that if you add together is negative 3? Negative 4 and positive 1, right? Now, the zero product property says if you have something times something and it equals 0, that means that that first something could be 0 or the second something could be 0. So if I actually split it, x minus 4 equals 0, x plus 1 equals 0, and I solve both. And when we solve, we add 4 to both sides, and we'll get x equals 4, which is an answer, and then subtract 1 from both sides, x equals negative 1 is another answer. So we have 2 answers, positive 4 and negative 1. However, don't jump right in and say that the answer is A, because it might not work. You have to test both of them. If you plug in 4 right there and plug in 4 right here into the original, 4 plus 5 is 9. The square root of 9 is 3, so you might want to jot that down somewhere. Let's see if the other side also gives us 3 when we plug in 4, and it really does. 4 take away 1, it really does give us 3, so 4 is definitely an answer. Let's try negative 1. If we try negative 1 and plug it in right here, you're going to end up with negative 1 plus 5. Negative 1 plus 5 is 4, and the square root of 4 is 2. So we have 2 on the left side of the equation, and if we plug in negative 1 right here, negative 1 minus 1, we get negative 2, and we know that 2 does not equal negative 2, so x equals negative 1 is an extraneous solution. So you have to test your answers in order to get the correct one. It's very easy to do all of this work and then get these 2 answers, see the answer, circle it, and then you get the wrong answer. That's horrible, right? Take a couple more seconds, take both of these, plug them in, see if it works. So the 4, when we plugged it in, it did give us 3 equals 3. It worked. When we plugged in negative 1, it gave us 2 equals negative 2, which means that it doesn't work.